Okay, what I'm going to be taking now is called partial fraction. No, partial fraction has about 4 approaches in solving it. So the question will tell you which approach are you going to use in dealing with that question. Now, remember that if you have, let's say x, let's say x over 2 plus y over 4. The LCM is 4. 2 goes in 4, 2 times x, that is 2x, plus this plus here. 4 goes in 4, 1 times y, that is y. Now, if you are now saying x plus y over 4, x of 5 over 4, then equals to x over 2 plus y over 4. Now, you know, this is a fractions to a single fractions. Now, this single fraction, when you decompose this single fraction to the smaller fractions, then it is called partial fraction. You use the method used is partial fraction. The way of simplify this or decompose this to this is called partial fraction. It's called partial fraction. Now, if not because I formed this question, so there's no way for me. It may be a bit, when you have a complex, like now, if I look at this critically, I can split it. But what if when you now have it in a complex form, how do you now simplify it? So we now use what we call partial fraction to simplify the fraction. So that is what partial fraction is for. So you are simplifying, you are decomposing a single fraction to more simpler fractions. So now let's see the first method or the first approach. We have about 4. The first one is I'm going to talk about is let me call it when you have factorizable or just single factor at the denominator. So now, when you see the question and look at the denominator, probably it's just a single factor. That is a linear, let me call linear factor. Linear factor, there's no power, or the denominator is factorizable. Then you can say you can use this approach. Now, what do I mean? If you have something like, let's say 3x plus 1 over let's say s squared plus 2s plus 1, something like this. So you will see that you first of all look at this. Is the denominator factorizable? Don't forget that this is our denominator. This is our denominator. So let's see how we factorize this. Maybe one of these days I'm going to teach on how you factorize. So just bear with me the way I'm going to do it now. Plus 1. It means 2 numbers I'm going to multiply to get 1. And if I add it, I get 2. So 1 times 1 will give me 1. And 1 plus 1 will give me plus 2. So I can use 1 and 1. So s squared plus x plus 1. I've not done anything. This is the same thing as it, but something is common. So s is here, x into x plus 1, then plus something is common here, 1 into s plus 1. So I'm having s, this and this, plus 1, then I'll pick 1, then s plus 1. So which means this can be changed to this. So this is what we call a factorizable that is so I can now rewrite this before I do anything. 3x plus 1 over s plus 1 s plus 1. You see now, that's what we mean by factorizable or a linear. Linear is that s is not carrying power. It could be any variable. So that is what I'm saying. That this is saying factorizable. Once you have it like this, then you cannot expand it as so. this is, we have already determined that this question is a factorizable denominator, or which we can call linear factor. Then you can now expand. This is how you expand. So if you have a question, so let me just look at, see question, one question here. I'm having 4 minus 2x over 2s plus 1, s plus 1, then s plus 3. So they've already factorized this, so you don't need to bother yourself. So these are linear factor, so they've already factorized the denominator. So now, how do you now expand this? This is how you expand this. Now, because we want to simplify this, you don't know how you do it, you just pick any variable. So by saying this first one here now, which is 2s plus 1, let's say so that the numerator will be something that we don't know over this first one, which is 2s plus 1 plus then b over x plus 1, then the last one, which is this c over s plus 3. So this you can only use, you can expand in this form provided that the denominator is factorizable. Then you can now solve this. Now if you are solving this now, what will be the SL? The SL now will be the 3, all of them, which is 2s plus 1, then s plus 3 by 1, s plus 3. Now, so that is the SL. So we want to put the 3 together. Now, if 2s plus 1 cancel 2s plus 1, what we are left with is s plus 1 and this. So multiply by a, which means your a now will now be equal to, let me write it so that now look at this. So the LCM now will be equal to 2s plus 1, s plus 1, then s plus 3. So then what we now have is that when this cancel this, you are left with these two. So multiply by a, it will be a into s plus 1, s plus 3, close the bracket. The sign here is plus, that is b now. So when this cancel this, under b you are left with this and this, which is 2s plus 1, this, then and this, because this has taken away this, s plus 3. Then if this has taken away this, you are left with these two for c, and this is the sign plus c into, you are having 2s plus 1 and s plus 1. You see now, so this is how you deal with them. Now before we proceed, let's expand this and see what it's going to give us. So we are having s plus 1, s plus 3. So if you expand this, s times s, that is s squared, s times 3 plus 3x, then 1 times s plus x, 1 times 3 plus 3. So this will give s squared, 3s plus s plus 4s, then plus 3. Then let's expand this. This one is for a. Let's expand the one for b, which is 2x plus 1 and s plus 3. So that will give us 2s times x, that will give 2s squared. 2s times 3, that will give plus 6x. Then 1 times s plus x, then 1 times 3 plus 3. So that will give 2s squared plus 7, that is 6s plus x plus 7s plus 3. So that is for B. Then let's see, look at C now. C will now become C will now be, that is 2s plus 1 and s plus 1. So well, let's expand. 2s times s, that will give you 2s squared. Then 2s times 1 plus 2s. Then 1 times x plus x. Then 1 times 1 plus 1. So definitely we have 2s squared, 2s plus s, that is plus 3s, then plus 1. So now I'm going to now arrange this, you see together now. So which means for A, B, C now, A, B, C. I want you to look at, because there is no more space. I will have cleaned this space. Let's see what we can see. This is A, this is B, this is C. So let's arrange them together. Now, which means, which one can I clean? Where can I clean? Okay, let me clean here. Let's clean this place. Let's clean this place now. Yes. So let's clean here. Now look at this. We want to, don't forget we're having A, B, C. So which is A, B, C divided by the denominator. Now this is square. This is A is having this. Don't forget we are multiplied by A. Let's say everything over times A, everything times B, everything times C. You remember, we find the denominator, the LCM, we've expanded, and this is our final decision. Now, this is square, this is square, this is square. So S is common. So we can now say equals to, I want to expand the numerator alone now. So if this is S square, this is S square, this is S square. S is common here, here, and here. So if you put S square into, when you remove S square from here, what remains? 1 times A, that is A. Then plus, you see now, plus, when you remove S square here, what remains? 2. 2 times B, you have 2B. I suppose I've expanded it, but we are not having space here. I've expanded everything. Then, when you remove S square from here, which is this, remain 2. 2 times C, which is C, plus 2C. Now you will see that if you open this, A square times A, that is A square. S square times 2B, that is 2S, 2S square, 2S square B, 2S square B. 2S square times 2C, we have 2S square C, 2S square C. That's that. Now if you look at it, there is S here, there is X here, there is S here. So which means S is common, that becomes plus X into, when you remove S from here, what remains? 4. 4 times A, you have 4A. Plus, when you remove S from here, we are having 7. B times 7, that is 7B. Plus, when you remove S from here, remain 3. 3 times C, that is 3C. You see now, so what we are now have left now is the constant. So plus the constant now, which is this is 3A, then plus this is 3B, plus 3B, then plus 6 times 1 plus C. So I hope you are getting it. Throw your question in the comments. Just throw your question in the comments. Then let's see it. Now don't forget that everything divided by the denominator, which is 2s plus 1, s plus 1, the 3 factors. So now if you now compare the right hand side, here is the right hand side, the left hand side rather, and the right hand side, everything here, you see that they are having the same denominator. So the denominator on the right will cancel the denominator on the left. So what we are left with now is the numerator, which is what? 4 minus 2s equals to these are the numerator. We have s squared into a plus 2b plus 2c plus this s into 4a plus 7b plus 3c plus this 3a plus 3b plus c. You see now this is where you now apply what we call comparison. You compare the coefficients. Comparing the coefficient. This is where you write comparing the coefficient. So this is where you compare the coefficient. So let's compare the coefficient now. So I'm going to clean from here. Let's clean from here. Now, we want to compare the coefficient now. So now the first coefficient, if you look at it here, the highest power of x you have in the whole equation is s raised to power 2. So let's first of all look at the coefficient of s squared on both sides, on both left and right hand side. Don't forget we're under factorizable. I think I can clean this one now. So now what we have now is that if you look at the left hand side, there's nothing like s squared. So which means on the left hand side we are having 0 equals to, if you go to the right hand side, the coefficients of s squared, we are looking at the coefficients now of s squared is what? A plus 2b plus 2c. We have a plus 2b plus 2c. You can call this one equation 1. Now we are going to compare s now. From here now, if you look at from the left hand side, if you look at the coefficients of x, is minus 2. So which means on the left we have minus 2 equals to, let's look at the coefficients of x. These are the coefficients of x here, which is 4a plus 7b plus 3c, equation 2. Now let's now look at constant. The coefficient of, look at from the left hand side, we only have 4 equals to, now look at the left hand side, we are having 3a plus 3b plus c. You see now, you can call this one equation 3. Now, if we are good to go. So we need to now solve this. Now you can use matrix to solve this, or use a substitution method to solve what we are having here. Now, let's look at the simplest one. I can make C the subject of formula equation 3 and substitute it into the remaining 2 equations. I make A the subject of formula, then and substitute it into the remaining 2 equations. So either way, we still arrive at the same answer. So let's say from equation 1. So if we make A the subject of formula, from 1 we have let me say is 0 equals to A plus 2B plus 2C. Now if you make A the subject of formula, I will leave A here, I will transfer the remaining 2. I have, if this come here, we have minus 2B minus 2C equals to A. So we can call this one equation 4. You see now, I'll make A the equation, a subject of formula from equation 1. Then I can now say substituting equation 4 into equation 2 and 3. Now equation 2 now, we're having minus 2 equals to, wherever I see A, I'm going to put minus 2B minus 2C. So this is 4. So which means 4 will multiply everything that is A. So A is minus 2B minus 2C. I hope you get it now. Then we are left with plus 7B plus 3C. Then we can open bracket minus 2 equals to 4 times minus 2b, that is minus 8b. 4 times minus c, call me, okay, yes, 2 2. Then 4 times minus 2c, that is minus 8c, plus 7b plus 3c. Then we can collect terms, equals to, this is minus 8b plus 7b, that is minus b. This is minus 8c plus 3c, that is minus 5c. You see now, you can call this one equation 5. Equation 5. Now, don't forget, from here, we are substituting equation 4 into equation 2 and 3. We are done with equation 2. Now, let's see equation 3. Equation 3 now, we are having, which is this, equation 3, we are having 4 equals to, wherever we see a, we are putting minus 2b minus 2c. This is 3 into, we will put, instead of a now, we put minus 2b minus 2c. Then, which is a, we are left with what? We are left with plus 3b plus c. Now, we can now open bracket, which is 4 equals to 3 times minus 2b, we have minus 6b, 3 times minus 2c minus 6c, then that is cb, cc, then plus 3b plus c. Then we can now collect terms. 4 equals to minus 6b plus this, we have 3b, that we are left with minus 3b, minus 6b plus c, we are having minus 5c. You can call this one equation 6. Now, since we have arrived at, we are having equation 5 and equation c, they are having two unknown from equation 5, two unknown from equation c. We can solve simultaneous. Can I say solving equation 5 and 6, equation 5 and 6 simultaneously. So now we can now solve this. We can now solve, let me clean from here, let me leave the two equations and our equation 3. I need to leave equation 4 alone. Equation 4 alone. Now, from here, our equation 5 is minus 2 equals to minus b minus 5c, which is equation 5, and equation 6 is 4 equals to minus 3b minus 5c, equation, which is equation 6. Now, I'm going to use elimination method. Now, this is simultaneously. Sorry, let me write this very well. I have 4 here. Now, you will see that if I subtract equation 6 from 5, this will be cancelled. That means if I say minus 5 minus minus 5, so I'm saying minus 5c minus, I want to apply, this is the minus I want to apply, but this expression here is having minus 5c, so it becomes 5 minus times minus plus 5, so this one becomes 0. So which means I'm going to apply this negative throughout the whole. So this and this cancel, become 0. It will now be minus b minus minus 3b. That is minus b minus minus 3b. So we have minus b plus 3b. So that will give us 2b. So this one become plus 2b equals to, this become minus 2 minus 4 because there's no minus here. So that will give us minus 6. So b will be minus 6 over 2, which is equal to minus 3. Now, I can now say put any of the equation, I can now say put b equals to minus 3 in equation, and we'll look at the one that is simpler between 5 and 6. So let's use 5, equation 5. So let me write this one somewhere so that this equation 4 that says minus 2b minus 2c equals to a. So we are going to use it very soon. Now, so we can now say, I say put b equals to minus 3 in equation 5, and this is our equation 5, which is minus 2 equals to minus b minus 5c. So wherever I see b, I put minus 3. So equals to, this is minus here, but b itself is minus 3 minus 5c. So minus 2 equals to minus times minus 3, so minus 5c. So by the time you collect terms, this one become minus 2 minus 3 equals to minus 5c. So this one become minus 5 equals to minus 5c. So c equals to minus 5 divided by minus 5, which is equal to 1. Now remember that from our equation 4, a is equals to minus 2b minus 2c. Now that we know the value for b and c, we can calculate a. So that becomes a equals to minus 2. Our b is minus 3, minus 3, minus 2, and our c is 1. So we have a equals to minus 2 times minus 3, that is 6, minus 2 times 1, that is 2, which is equal to 4. Therefore, a equals to 4, b equals to minus 3, and c equals to 1. Now, if you now go back to our question, don't forget, we've expanded our question. Let me write it out, which we say 4 minus 2s over 2s plus 1 s plus 1 s plus 3 to be equals to a over 2s plus 1 plus b over s plus 1, then plus c over s plus 3. So you can go back to the initial video to look at how, when we expanded the expression here to this. Now we've gotten the value for a, value for b, and value for c. So we can just put them in. So our a is 4, that becomes 4 over 2s plus 1, then plus, then our b is minus. So the negative will affect this. So it become negative 3 over s plus 1, and our c is 1. So this still remains plus 1 over s plus 3. So if you find the LCM of this and you do calculation, the whole expression is going to give you this. So this is how you apply this is how you solve a partial fraction. So now the first method we look at it, the first approach is when the denominator is a factorizable expression, or if it has already been factorized, or is linear, there may be s plus y, s plus 2, y plus something. So then you can now use this approach. Now when you are now having square, or there's one we call a repeated factor, then you cannot use this approach to expand it. But when you have a factorizable denominator or linear denominator, then you can now use this method to expand whatever you have, and you have arrived. So be expecting the next approach. Thank you.